Happy day to you all. This is Orekoya Physics Mathematics Fundamentals on YouTube. Today we are going to deal with mechanics. Under the mechanics, we are focusing on circular motion. And under this circular motion, we are going to make reference to linear motion and angular motion. Now, let's go into the discussion. Let's think about a body undergoing a motion along circular path. Let's say the body is at point P1 before moving down to point P2 along this infinitesimal parts of the circumference of the circle, the arc. Let's say this small part, infinitesimal part, is the C, and this particular part sustains a small angle at the center C, at the center O of the circle. Let's say the small angle is the theta. Now, the radius of that circle is radius r. Now, because the arc is very small and the angle is very small, this arc can be thought of to be a straight line. So the sector, this particular sector I'm bringing out, this is at point P1 of the location of the body, and this is the C, and this is the theta, the angle sustained at the center of the circle, and this is the radius of the circle. Because the C is a very small quantity, it can be approximated to a straight line. So this particular arc sector can be thought of to be a right angle triangle. So my DC now has been taken to be a straight line. That is a linear motion, angle along a straight line. So this is the radius of the circle, and this is the angle sustained at the center of that circle. Now, in a nutshell, from trigonometry, tan d theta from this my right angle triangle is opposite over adjacent, opposite DC over adjacent R. That is DC all over R. Now, because my theta is very small, tan d theta is same thing as theta, so I can write this as d theta is equal to DC divided by R. By cross multiplying the radius, I can have my DC now to be R d theta. Dividing both sides of this equation by an infinitesimally small time dt, I have dt is equal to dt on the other side. So this particular dc is the linear displacement divided by time, that is a velocity. Now I have my r, then the theta over dt means the theta, as this particular body is moving along this circular path, the radius is shifting from position P1 and to position P2, and the angle is changing by the theta during a time interval of dt. So the theta is angular displacement divided by the time, is the angular velocity. So we normally write angular velocity using symbol omega. So in a nutshell, the linear velocity v, this is a linear velocity, that is velocity along a straight line, is equal to the angular velocity times radius of the circle, angular velocity, and the r is the radius of the circular path. So with this now, we can also derive the expression for linear acceleration. We know that linear acceleration a is change in velocity divided by change in time, that's the v dt, and then my velocity here is omega r. So I can have the omega r divided by dt. But because the radius of that circle is constant during the course of the motion, I can have my a and put the radius outside the differentiation sign. So I have r the omega divided by dt, and the omega divided by dt, that is the change in angular velocity, is angular acceleration. So we have a is equal to r alpha. This alpha is the angular acceleration. So this relationship between linear acceleration and angular acceleration. Now when we consider the velocity, due to change in position of this body along the circular path, I can draw a circle showing change in velocity. Let's say at this particular point here is the velocity at point P1, and this particular point here is the velocity prime at point P2. Let's say this velocity sustain infinitesimal angle at the center, that is the T. Now the change in velocity is going to be along this arc, that is the V. So if I bring this sector out, I can approximate it to be a right angle triangle like I did the other time. So in this case now, along the base of that triangle is the initial velocity V. So I write this V, and the change in velocity will be the V, and the angle considered at the center is the theta. So tan the theta from trigonometry is opposite the V divided by V. Now because the theta is very small, tan the theta is same thing as the theta. So I can have my d theta is equal to dv divided by v. Cross multiplying, you have v d theta is equal to dv. Dividing both sides by infinitesimal time dt during the course of the motion, I have dt divided by dt, and dv divided by dt is linear acceleration, and the theta divided by the theta divided by dt is the angular velocity times linear velocity. And we know that I've derived an expression for linear velocity to be omega r. Substituting omega r here, I have omega r times this omega that is there before. Then omega times omega will give us omega square r is equal to a. So in a nutshell, we are having two expressions for linear acceleration. Linear acceleration is the radius of the circular path times angular velocity square, or linear acceleration is the radius of the circular path times angular acceleration. Now, this expression can also be used to derive the centripetal force. We know that force F is equal to mass times acceleration. I can use either of these acceleration for my F here. So my F can also be written as mass times r times angular acceleration, which is same thing as mass times r times linear angular velocity square. So I have m omega square r. So F can be written as m omega square r. And then if I want to eliminate omega, from this expression, my omega here as a subject of formula will be linear velocity divided by the radius of the circle. So substituting it here, I have m v divided by r square times r. Opening the bracket, I have mv square all over r square times r. This r cancel the r down, so I have mv square all over r. This particular expression is the expression for what is called centripetal or centrifugal force. Centripetal force is the force that is keeping a body together with the centrifugal force on a circular path. What am I trying to say? Consider a body of mass m. Centripetal force is a force that directs this body toward the center of the circle, and the centrifugal force Fc is the force that directs this body away from the center of the circle, keeping this body in a circular path. So this is the expression for centripetal or centrifugal force. Centripetal force or centrifugal force is given as mv square divided by radius of the circle. Thank you so much. Please don't forget to like, share, and comment on my video. Thank you so much.